Why the definition is very important. Would you tell me?
So you know what you're talking about?
Yes, it is know what you're talking about. Okay. The reason is here. The math is a language, actually. Is a language. Is a language of the science. The math is the language of the science. The concepts or the vocabulary of the math is the basic, the words. Basic word. If we don't know the definitions, we can't understand the math because it's like I said, different language. Because we don't, for example, we know we are Chinese Americans. So if somebody write a character, for example, I write this one. But if we don't know the character, don't know the meaning, so you don't understand, right? Similar as math. So that's why the definition of the vocabulary is very important. So from the definition of the vocabulary, we can derive the formulas, the theorems. Make sense? Of course, we know not just to know the definition. We need to know why the mathematicians make the definitions. The better way, because some definitions, we even though you know the definition, because if you know why the mathematicians make the different definition. For example, the definition prime number, everybody know that, right? The prime number, we have the definitions, even though there are different kind of similar definitions. Who can tell me what's the definition of prime numbers?
The multiples are only one in itself.
One positive integer that has exactly one or two factors.
Yes, that's a good definition. The definition of prime numbers, we say first need to do positive integers, not decimals, not fractions, right? And have two different factors. So one have one even so one equals two factor 1 times 1, but they are same. But we need to know why. Why mathematicians actually right now, even though today, a few mathematicians still insist like a 1 be prime. They say some mathematicians, even though you check the Google, some students still. But why mathematicians, most of the mathematicians, like the definition said, two different positive integer factors. So we need to know why. For example, we factor, for example, 80, for example, we factor 80. We can use factor 3. There are many strategies we can factor 80. For example, we factor 80, we factor 3, 8 times 10, right? Then 80, we can factor 8 times 10. 8 is 2 times 2 times 2, right? 10 equals 2 times 5. If 1 is prime, so the 2 continually factor 1 and 2. So the infinite continually factor 1 and 2. So the infinite. Make sense? That's why the 1, we don't like 1 be prime. If 1 be prime, when we factor a number, for example, factor 80, they're infinite. Because usually there are many ones, right? Many ones, then times 2 to the 4th power times 5, right? So that's why. So actually, in real application, 1 could be prime. But just for this case, when we prime factoring the number, if you include 1 included by the included in the prime numbers, so the prime factoring you cannot finish the prime factoring. That's why. Actually, that's why use the definition. So better way you need to know why mathematicians make the definition. And how from the definition can derive the formulas. So when we learn in math, you learn many formulas, right? Especially in trigonometry. There are many formulas. It depends on your learning.